What is the difference between geostationary and polar orbit satellites? Have you ever wondered how satellites keep track of our planet? Today, we are going to break down the differences between geostationary and polar orbit satellites. These two types of satellites play unique roles in observing Earth, and understanding their differences can help you appreciate the technology behind them. First, let's talk about geostationary satellites. These satellites orbit Earth at an altitude of about 35,831 kilometers above the equator. What makes them special is that they move in sync with Earth's rotation. This means they stay fixed over one spot on the equator, making them perfect for constant monitoring of a specific area. They are commonly used for weather observation, telecommunications, and broadcasting. For example, during severe weather events, these satellites can capture images of the same area every 30 minutes or even more frequently. Now, let's shift our focus to polar orbit satellites. These satellites orbit much closer to Earth, usually at altitudes between 200 and 1,000 kilometers. Their unique path takes them over the North and South poles, moving from pole to pole as Earth rotates beneath them. This allows polar orbit satellites to cover the entire surface of the planet over time. They are essential for detailed Earth observation, environmental monitoring, and collecting atmospheric data. Typically, they can update data for a given location about twice daily. When it comes to their orbital periods, geostationary satellites have an orbital period that matches Earth's rotation period, which is about 24 hours. This allows them to hover over the same longitude. On the other hand, polar satellites have much shorter orbital periods, around 90 minutes. This means they circle Earth multiple times each day, enabling them to scan the entire globe as Earth turns beneath them. In terms of applications, geostationary satellites are widely used for weather forecasting and live television broadcasting due to their fixed position. Polar orbit satellites, however, are crucial for global climate monitoring, environmental research, reconnaissance, and detailed mapping. Their ability to provide comprehensive coverage of Earth's surface and atmosphere makes them invaluable for scientists and researchers. In summary, geostationary satellites maintain a fixed position above the equator at high altitude for continuous observation of a specific region. In contrast, polar orbit satellites travel over the poles at lower altitudes, enabling complete global coverage as Earth rotates beneath them. Both types of satellites are vital in space technology, serving complementary purposes in Earth observation and communication.